Hey, this is Mr. Mitchell with a video about the Earth's waters. Now you can see a picture of the Earth over here. All the world's oceans connect, and you can see that whenever you look from outer space, the Earth is very blue. You can see that there's a high percentage of water on the surface compared to land, and in fact it is 71% water that you find on the Earth. 71% of the Earth's surface is water. That's almost 3/4 of the globe, and that's good because we need water. Our own body is mostly water. Our own body is roughly 2/3 water, and that's because our blood is made up highly of water. But of all this water here on Earth, only 3% is fresh water. You know, we can't drink salt water. Salt water does not help our body like fresh water does, and there's only 3% of it that is fresh water. Now, water has a cycle. You may have heard of the water cycle. I want to try to explain that. We have three different primary parts of the water cycle. We have evaporation, condensation, and precipitation. And the total amount of water on Earth really doesn't change that much. But you have all that water that is in almost a constant change. And it's even faster than the rock cycle. The rock cycle is comparatively slow compared to the water cycle. Let's take first of all that evaporation. You know that this water that sits in puddles, that sits in lakes, that sits in river, that sits in the ocean, with heat is going to evaporate up into vapor. Now, as it evaporates up, you generally can't see the water going up. It rises as vapor. And almost all of your evaporation is going to come from out here in the ocean. It's just so much ocean compared to puddles and rivers and stream. And the amount of evaporation depends upon the heat. Generally, the hotter it is, the more water will evaporate. Now, let's talk condensation. We had evaporation here. We have condensation here. Now, condensation happens, well, it's why the clouds form. You have vapor. Well, I'm really not writing very well. You have vapor that comes from evaporation. Condensation makes it back into liquid, but it's very small amounts of liquid. It's little bitty beads of liquid that is not really heavy enough to fall down just yet because it's condensed in these clouds. Now, you have condensation when you have a temperature change. If you did not have a temperature change, you would not have clouds. But what happens is, as you get water from down here, it evaporates up. The higher you get, the colder it will get. Now, whenever you have temperature change from hot to cold, that's when you get this vapor that becomes water, and they condense into clouds. And there's going to be a term later on as to when you get to that point. It is colder in this layer than it is in this layer down here. That's why you have this condensation. And of course, the one that we probably know the most about is precipitation. Precipitation is when all that rain gets heavy enough to where it drops. And of course, it can be in the form of snow, sleet, and hail also. So we have this whole cycle. Precipitation, it runs off into the ocean, and some of it evaporates from there. Evaporation, clouds form, and then you have precipitation again. So you could have a drop of water that ends up in all of these parts of the water cycle in not a whole lot of time. Now, plants also have a little bit to do in this water cycle. Plants pull water from the ground and they release it through their leaves, and then once it's released, it goes into the evaporation part of the water cycle. Oh, let's see, I think we have another slide to go to. Yes, here we do. Just a few notes about, a few questions about water. First question is, does salt water evaporate? Here we have all this salt water around these icebergs. Of course, it's not very hot, but still you're going to get some that evaporates up. What evaporates up? Is that salt water or is that fresh water? Well, it's fresh water. All the stuff that comes up is going to be fresh water. It's going to be fresh water. It's not going to be salt water, which is good because whenever it comes down in the form of precipitation, we definitely need it to be fresh water. We don't need it to be salt water. I'm going to change colors. That doesn't look as good. Okay, I want to explain to you lake turnover. Now I'm going to mark off this uniform temp oxygen bit right here because I don't think it helps us here. But here you have the sun. The sun is bearing down on these lakes. Now what's going to happen in the summertime, let's do that later. In the summertime you're going to have the sun bearing down. Of course the top of the lake is going to be warmer than the bottom of the lake. Warm up top, cold down here. But what happens when it gets wintertime? When it's wintertime, you're not going to have the hot up here and the cold up here. There'll be a point in the fall in which it is colder up here. So you have the hotter that's stuck down here and the colder that is here. Now colder water is more dense. So more dense will sink to the bottom. So that means you basically flip all the water that is in this lake or pond. The hot will rise to the top and bring sediments and debris with it, and it'll kind of shift all the nutrients around. The cold will sink to the bottom. So in the spring and fall, you have a rotation going from the hot making it to the top. I guess it's more the cold making it to the bottom because that is more dense there. So that's what a lake turnover is, the cold water going toward the bottom of the lake or pond, and that way means the hot water will rise. Another random question about this, does ocean water freeze as salt water? Down here we have all these glaciers. Are these glaciers salty or are they fresh? Well, unfortunately, they're fresh. All that salt water that's in the ocean, it doesn't evaporate as salt water. It doesn't freeze as salt water. It evaporates and freezes as fresh water. So if you were in a boat over here and took a chunk out of this iceberg, yes, you could put it in your mouth and have it just like ice coming out of your freezer at home. Which brings us to these icebergs. Now these icebergs, I'm trying to find on my notes where I have it. Yeah, these icebergs are a source of fresh water, and it's kind of odd. The iceberg, only about 1/8 of the iceberg is on top of the water. Only about 1/8 is on top of the water, and usually about 7/8 is underneath the water. So here you have this average chunk of ice. There's no telling how big it really is down under the water. It's just huge. That's just the way they sit in the water. And it's kind of odd. Here you have these huge areas of fresh water. You have areas in the desert thousands of miles from there that really could use some fresh water. And people have thought before, well, is there any way we can get these icebergs to desert areas? And nobody's figured out how. And that would really, I mean, you could probably have, I think the book actually gives you some statistics about it, how you could feed 10,000 people for 10 years or something along those lines. But massive amounts of water here that could really help people. And maybe someday people can figure out how to do that. So what happens when the ground absorbs water? We'll find out on this next slide. We have underground water. Now, I want to have the definition between permeable rock and impermeable rock, and I bet you can guess what the answer is. Permeable rock, water can flow through it. allows a water flow. And impermeable rock, it is no water flows through it. It's just not going to flow through impermeable rock. And we have more permeable rock than you might think. You might think that rocks and water just don't rocks just don't absorb water at all, but some of them do. Sandstone is one. Some of the sedimentary rocks are more rock permeable. So that means if you have precipitation, it's generally not going to stay in a puddle very long. It's going to be absorbed by the ground. Now, of course, sand and silt and clay, they're going to be permeable. But even once you get down into the rocky areas, you have those rocks that are permeable, and water can go through it. Now, it's not going to go through rocks very fast. It's going to go through rocks very slow. But you still have that down there where water can go through that. Now you have this little area here. This is a line that changes with however much rain you've had lately. This is the water table. So whenever you have rain, the water is going to sink, and at some point it's just going to be at a point where it's saturated. Have you ever dug a hole or had your parents dig a hole, and in the bottom of the hole was the water? Was water in the bottom of the hole? That just meant you've hit the water table. See, in that case, the water table would have been about right here because it's just really must have rained a lot recently. But that's what happens whenever you find water in the bottom of a dug hole. So that's the water table. Now you may wonder about this term aquifer. An aquifer is a layer of permeable rock, and it usually refills whenever you have rain or some other water source. It doesn't always have to be rain. There's a huge one underneath our Midwest, under Nebraska and Oklahoma. Now, what people do is they dig wells down into aquifers. And you can pump out water through the aquifer because it sucks it in from this rock, which is down here. And you have an almost unlimited supply on most all of your wells. But anyway, underground water, all this water in the water table, is flowing downhill just like it would on top of the water. I mean, if you have water here and it flows down in streams, it's flowing downhill toward rivers or toward the ocean. Same exact thing is going to be true under the ground. However, it's just going to be incredibly slow. So whenever you think about digging wells, those are the places where you're going to try to get to, is these aquifers. Oh, let's see what's at the next slide. It may be our questions, and yes, it is our questions. Here's some questions for this section. Number 1, evaporation is what? Number 2, what temperature change happens to allow condensation? Number 3, how do plants help the water cycle? Number 4, lake turnover happens in what times of the year? And number 5, what is an aquifer? Well, I hope you've learned a little bit about the water cycle.